Functions, functions, functions. They're all around us, all types of different functions, but in this video, we're going to be focusing on log and exponential functions. Let's start with the base function. F of x equals b to the power of x. That is the parent function. What makes exponential functions unique is the fact that the exponent is its variable, unlike other functions like quadratic and linear functions. And unlike its function counterparts, as having its exponent being its variable makes it very prone to increasing rapidly. So now that we've covered the base function, let's get to the transformations of an exponential function.
The first value, the a value, impacts the vertical stretch if it is greater than 1, or the vertical compression if it is less than 1 but more than 0. Also, the a value is negative. If it is negative, the same rules apply. However, it is now reflected in the x-axis.
Next, we have the b value. It's the base, and what it does, it determines the rate of growth or decay.
The second value, the k value, impacts the horizontal stretch or compression by the reciprocal of the number in the equation. Therefore, if it is a fraction in the equation, such as 1/2, then the graph is horizontally stretched by a factor of 2, whereas if there is a whole number in the equation, it is going to be compressed by the reciprocal of the whole number. Also, if k value is negative, it is flipped in the y-axis.
Next, we have the d value. This is responsible for horizontal translations. If the d value is negative, it gets translated that many units to the right. If it's positive, it gets that many units translated to the left. Finally, we have the c value. It's responsible for vertical translations up and down the y-axis. Now that we've discussed the transformations of exponential functions, let's look at its other characteristics, like domain and range. A domain of an exponential function looks like something like this, where it can be any element of x, and its y can be anything greater than 0. And it also can't, the a value also can't be 1, because you'll get something like this, because 1 to the power of anything is just 1. Now that we've gone over the characteristics of exponential functions, we're missing out on one key point here. When you take the inverse of an exponential function, it creates a log function. That can be evident here, and that can be evident right there. And with log functions, it creates a whole new world of applications that we'll get into. Now that we've identified what exponential functions are and their characteristics, and now that we've identified log functions, let's identify its characteristics. So basically, whatever characteristic an exponential function has, it's the opposite for the log function. So for example, exponential functions, its asymptote is that x cannot be 0. But for log functions, its y cannot be 0. So regardless of its end behavior, domain, and range, its characteristic is opposite to exponential. And you can see it in this example here.
Furthermore, these functions prove to be extremely vital in all sorts of fields, such as the medical field. By analyzing bacteria growth and decay, emergency room doctors may use exponential or log functions to determine, for example, how much bacteria or infection, per se, a hazardous material may be left in a person's body over a period of time to determine the state of emergency. The reason why these functions must be used for such large-scale models is that they can produce a solution over a longer term than any other function.
Another great application of a log function is the measurement of sound intensity through decibels. By writing decibels as a function of loudness multiplied by log of sound intensity divided by I0, or the lowest sound threshold a human can hear, we are able to measure sound and its intensity. This proves to be extremely useful in the field of music and sound. For example, artists may use decibels to measure intensity and loudness of different rhythms in their music to find perfect balance. Furthermore, concert venues heavily rely on this to determine a comfortable but intense sound experience to make that event unforgettable for its viewers. Thank you, Mr. K, for viewing me and Ramin's Exponential and Log project. Throughout this research course, we have been able to identify different applications of log and exponential functions and what it means in real life. Thank you for listening.